So good day guys, and welcome to this video. In today's video, we are going to be providing a solution to this problem that we have before us right here. We are told that given that 625 over 1296 raised to power 1 power minus 1 over 4 multiplied by the cube root of 125 p cube r to power minus 3 and q to power minus 2 rather and r to power minus 6, we are asked to simplify this problem. Let's get right into the solution. First, let's have the solution. We are told that 625 over 1296 raised to power minus 1 over 4 multiplied by the third root of 125 p to power 3, q to power minus 3, and r to power minus 6. We have to simplify this problem. The very first thing I would like us to know is that this question is under a topic known as indices, right? So for this first side, I'm going to be simplifying this side first, and then I simplify this side together with it. Now, if you can recall from one of the laws of indices, if you have a over b raised to a negative n as a power, the law states that we can take the reciprocal of a over b, that is, we can turn what is inside the bracket upside down, right? Provided that there's a negative sign on top here as a power. So when I turn this upside down, I'm having b over a. So me doing that has taken away the minus sign from there, so I'm left with n. So let's start with an example. So let's say I have 2 over 3 raised to a negative 1. So the negative here means the inverse of what is here. That is, I should just turn this upside down, and whenever I turn it, the minus here is going to disappear, right? So when I turn it, I'm going to have 3 over 2 then raised to power 1, right? So, and if you want to bring back the minus, just turn it back again. You have 2 over 3, then the minus will appear again. So whenever you turn the expression, a negative always appears. But I want to leave you with something. Whenever you have a number, if I give you 2, this 2 also means 2 over 1, right? So whenever I give you 2 raised to a negative 1, what I'm asking you to do is that you should turn this number upside down because of the negative that is on top of this place here, right? And if you can recall, I told you that if you have 2 is same thing as 2 over 1, right? So when you turn this upside down, you just have 1 over 2 that is left. Is the concept clear? So if I give you 3 to power minus 2 for instance, and I say work on this man here, what you are going to do is to remember that for every whole number it should be over 1. That means this 3 cannot just be like this. There has to be an over 1 here. So since there's a negative there, we are going to just turn the operation upside down, and we're having 1 over 3 then raised to power 2. That's all. Now, having understood that, let's get back to solving that problem. So when I do that, because of the negative here, I'm going to have 1296 all over 625. That is, I've turned the expression upside down. So when I've done that, the negative there is going to go away. So I'm having 1 over 4 as my power left. Multiplied by, I've always told my student that whenever you have an expression this way, that is numbers combined together with letters, separate everything, that is the sign in between each term, make it visible, right? I'm having the third root of the sign in between everything here is multiplication. What I'm saying is the sign in between the 125 and the p cube here is going to be multiplication. So if I expand this man here, this is 125 times p raised to power 3, that is the sign in between them. Then the sign in between this p and q is also multiplied by q raised to minus 3. Then the sign in between the q and the r is also multiplied by r raised to minus 6. So I just indicated that what is in between all of this is a multiplication sign. Do you understand? So from here, from this part now, we recall another law of indices that says if you have any number raised to a fraction, there's no negative here again. So any number raised to a fraction, let's say a raised to or let's use another variable. Let's say a raised to x over y. Let's say this is the problem. So any number raised to a fraction, we said we take the root of this number. So I'm taking the root of a. Understand something? But the denominator of this fraction on top of here will determine what kind of root you are actually taking. So the denominator of the fraction here is y. So I'm taking the y root of a, then raised to the numerator, which is x. I believe this is clear. Another example, if you have, let's say I want you to understand the concept. Let's say I give you x raised to 2 over 3. Let's use a practical number. Now, since there's a fraction on top of this, it looks just like this law. So we said we take the root of the number first, right? Then the denominator of the fraction is 3, right? So that 3 is telling us that we are taking the third root of x, then raised to the power 2. Are you seeing that now? All right. So we're going to apply that here. Let me get rid of these. So from here, we have that I'm taking since I'm having the denominator here as 4, I'm first going to take the root of this whole number here, right? That is 1296 over 625. Then the denominator of this fraction is 4. That means I'm going to have 4 inside here, right? That I'm taking the fourth root of this, then raised to the numerator. All of this raised to power 1. Are you seeing that now? Then multiplied by. Now, another law of indices here is that we're going to apply another law of indices to simplify this part here. Just watch, right? So for this part here, we said anytime a number is raised to a root, or a number has a root on top of it, we can either remove the root. That is, we are doing the inverse of the root. Remember I said that whenever a number has, let's say, x raised to power a over b, we said the denominator here will be the root of that number, then raised to the numerator, right? So we can reverse the root, we can take back the root into this form. So if I give you a raised to let's say I give you the x root of a raised to power y, right? I said you reverse this to look in this way. What you are going to do is first write the number a, then you know that x is going to be the denominator, right? Just say y over x. Do you understand? So you're having y over x. So you have reversed this thing now in this way. Do you understand? Now we are going to apply that here. We are going to take the reverse of this. Hope you know that this whole thing is raised to a power 1, right? All right, let's get rid of this. So from this man here, if I remove the root, if I do the reverse of what I just did, I'm going to have this whole thing first. 125 multiplied by p to power 3 multiplied by q to power minus 3 multiplied by r to power minus 6. All of these guys is going to be raised to the inverse, that is 1 over 3, right? Which is the root. I just removed the root, and that root is what I have here. I believe we understand. So from here, we can continue simplifying further. Now, what does this one actually mean? What does this actually mean? What it actually means is you have to look for one single number for this number up here. You have to look for one single number that you are going to multiply in 4 places to give you this number. So let's start from 1. That is 1 times 1 times 1 times 1. The same number in 4 places. Is it going to give us this? That means we can't use 1. Let's try 2. 2 times 2 times 2 times 2. This is going to give us 16. It's not giving us this. That means you can't use this. Let's use 3. 3 times 3 times 3 times 3. So 3 in 4 places. That's 81. It's not giving us this guy here. Let's check 4. 4 times 4 times 4 times 4. So 4 raised to 4. That is 4 in 4 places. That's 2, 5, 6. It's not giving us this number. Let's use 5. 5 times 5 times 5 times 5. That is 5 in 4 places. So 5 in 4 places. That's giving us 6 to 5. Okay, we've already gotten for this guy here. we have not gotten for this guy. Let's check 6. 6 times 6 times 6 times 6. That is 6 in 4 places. That's giving us 1296. That means the number we are looking for to multiply in 4 places to give us this number, that number is 6. Because if you multiply 6 in 4 places, it's going to give us this. Let's assume I give you something that looks like this. The question is, what single number are you multiplying in 3 places? The same number you are multiplying in 3 places to give you 27. So if you check it, if you try 1 times 1 times 1 in 3 places is not 27. 2 times 2 times 2 in 3 places is not also 27. Then 3 times 3 times 3, that's the same number in 3 places, that's giving us 27. So the number we are looking for here is just 3. That's your final answer for this one, right? That means the number I'm going to use to replace this one here is just 6, and the number I'm going to use to replace one here is also 5. So let's get rid of this. So from here, the number I need from this one here is just 6, and the number I need from here is just 5. Are you seeing that? So remember that all these two numbers are raised to power 1. So 6 to power 1 is still 6. Let's just put it there, right? So I've simplified using this man here. So the number I'm looking for to multiply in 4 places to give me this is 6. The number I need to multiply in 4 places to give me this is 5, right? So those two numbers raised to the power there, they're multiplied by. Now I'm going to distribute these roots, this power here, for everything inside the bracket. That is, this 1 to 5 is going to take what is outside the bracket. This p to power 3 will take what is outside the bracket. This will take also. So everything inside is going to partake from what is outside the bracket. So I'm having 125 raised to that power outside. Are you seeing that? Everything inside is taking what is outside. Multiplied by, here I'm having p to power 3 raised to 1 over 3. Multiplied by q raised to minus 3 raised to power 1 over 3. Multiplied by r raised to power minus 6 raised to power 1 over 3. Are you seeing that? So from here, remember we are asked to simplify the problem. So from here, 6 to power 1 is 6, and 5 to power 1 is as well 5. Multiplied by, remember we said any number is to a fraction, right? We take the root of the number. Then the denominator of the fraction on top will tell us what kind of root we are taking. So we are taking the third root of this number, then the raised to the numerator, which is 1, multiplied by, from the law of indices, we said when we have an inside power and an outside power, we have to multiply the two powers together, right? So we have p raised to 3 multiplies 1/3. That is, when you multiply 3 and this, 3 times 1 over 3, we're having just 1 left, right? So this guy has a power of 1 left. And then q, when you multiply minus 3 times 1 over 3, you have just minus 1 left. And then when you multiply minus 6 times 1 over 3, you have minus 2 left. So this should be the last part. So from here, we can say that 6 over 5 multiplied by one number can you multiply in 3 places to give you this number. That number is 5. So we have 5 to power 1, and it's still going to be 5. Multiplied by p, multiplied by q raised to minus 1, multiplied by r raised to minus 2. Remember, all of this as over 1 there, right? Now, we are going to do something. From this part here, we are going to have 6 over 5 multiplied by 5 over 1 multiplied by p over 1. You know, all of this has power of 1, 1, 1, right? But this guy has a power of negative. And if you remember, I told you that whenever there's a negative, we are going to just turn, we are going to turn this expression upside down. That is, 1 goes up, q comes down, right? So we're having 1 over q, and then q is going to take the power there, which is power 1. Then multiplied by, this guy too has a negative, so we're going to turn this upside down. So 1 goes up, r comes down. So we have 1 over r, and r takes the power. So from here, we multiply everything that is on top as the numerator, or we can even cancel out. This 5 can cancel out this one, right? So I think that's the only thing I can cancel out. So multiply the remaining. So we just have 6 times p times 1 times 1. So we have 6p, that is for the numerator, all over the denominator. There we have 1 times 1 times q times r squared. We have qr squared. And this is the simplified answer. Let's check our option. We have 6p over qr squared. Option E should be the correct answer. Thank you for watching and see you on the next one.